Buoyancy Project. Wintech 2014, NZDE Hydraulics Class. Assignment Brief. We will document a home experiment on how to calculate the buoyant force acting on an object. Theory. From our hydraulics notes, we have the formula to calculate the buoyancy force acting on an object. If an object is placed into water, the buoyancy force is related to the volume of water it displaces. The object. We used a few weights from an old kitchen scale, placed inside an old Coke bottle that John had. John drinks a lot of Coke. What volume of water will be displaced by this object? Let's place the object in water. The starting volume of water in the container is 1000 milliliters. The Meniscus is now at 1520 milliliters. The displaced volume is 520 milliliters. Now we can calculate the buoyancy force. The buoyancy force is 5.1 newtons. Just out of interest, what is the weight force of our object? Wow, this is very interesting. When the object is floating, the weight force is equal to the buoyancy force. What happens when an object sinks? We will take the kitchen scale weights out of the container. Then, calculate their buoyancy force by finding the volume of water they displace. The water level went from 1000 milliliters to 1070 milliliters. The scale weights displaced 70 milliliters of water. Therefore the buoyancy force is 0.7 newtons. We know the weight force is 4.9 newtons, because the weights add up to 500 grams. Let's place the kitchen scale weights in water and see what happens to the weight force. When the weights were suspended in air, the weight force was 4.9 newtons. When the weights were suspended in water, the buoyancy force acted against the weight force. The spring balance went from 4.9 newtons to 4.4 newtons. Thank you for watching. WINTEC rules.